Okay, so for 12 part A, we are given f dash of x, and it says basically write it in this form, a over x plus b over k minus x. This is partial fractions. That's what this lesson would be if you want to know how to do it, or if you want to watch a lesson on this. It's partial fractions. It's turn this into these two fractions, and one of the reasons we do it, or one of the reasons we use it, partial fractions, is to integrate this function, which we're going to in part B. Anyway, let's do this first. So we can say 1 over x times k minus x equals a over x plus b over k minus x. Now the thing is, we don't know what a and b are, but we can find them. Because this is equal to, if we get a common denominator, think of algebraic fractions. The common denominator is this times this, which means in order to make this a single fraction, I need to do a times k minus x plus b times x. And this is equal to this, which is, well, I'll write it again, 1 over x times k minus x. Now, if this is equal to this, then the denominators are the same, so the numerators must be the same. So 1 must equal a times k minus x. I'm actually going to multiply it out here, guys. ak minus ax plus bx. So it says in terms of k we've to find a and b. So what I like to do is we equate the coefficients. So we equate the coefficients of x, and we equate the constants. So 1 must equal ak, because the constant term on the left is 1 and the constant term on the right is ak. So 1 must equal ak, therefore a must equal 1 over k. And the coefficients of x on the left are 0. There is no x term on the left. And the coefficients of x on the right is minus a plus b, minus a plus b. So b actually equals a, according to this. Yes, I'm just checking I did that correctly. I think I did. So a equals b, so b is also equal to 1 over k. So I can express this as, let's just write it over here, guys. F dash of x equals a, which is 1 over k over x, but that's just 1 over kx. And b is 1 over k, so it's plus b, which is 1 over k, but that's just 1 over k times this, k minus x. So there we have it. That's the answer to A. B, it says find an expression for f of x. So to get f of x, we're going to integrate this. So f of x is equal to the integral of this whole thing, which is actually the integral of 1. Well, we can take out the 1 over k, guys. That will make our lives a little bit easier. Take out the 1 over k, and we're left with 1 over x plus 1 over k minus x dx. If you want to put a bracket here, you can. This is 1 over k. Now the integral of 1 over x is ln of x. ln of x. Now you have to put in the modulus sign, guys, be careful. The integral of 1 over x is ln of mod x. This is in the formula booklet. And then this is, well, I'm gonna make it minus because it's the ln of this, ln of mod k minus x. And then chain rule, or inverse chain rule, we have to divide by the coefficient of x here, which is -1, which basically gives us a negative this. So that is the integral, and then we do plus c. If you want to then write it as ln x over k minus ln k minus x over k plus c. Okay, that's parts A and B.